Alright, today we are tackling section 3.3. We're going to focus some more on the unit circle and on trig functions as related to the unit circle. Okay, so we have discussed the fact that we know the radian measure theta is related to the arc length S, so that S is equal to r theta, where theta is in radians, therefore, that's what those little triangle of dots mean. Therefore, when r equals 1, S equals 1 theta, or just theta. So my arc length is the same as the angle theta if I'm on the unit circle, if my radius of my circle is 1. Circular functions are basically just our trig functions written as functions of arc lengths. Now, because my arc lengths are real numbers, so S is a real number, therefore my domain is all real numbers instead of degree measures of angles. So that arc length can be anything. S can be anything. So, for any real number S represented by a directed arc on the unit circle, so this is my arc length S, the arc that is subtended by the angle in standard position, these are how I define my trig functions, my 6 trig functions. Now, remember, for example, sine of theta is y over r. Well, if r is 1, sine of theta is just y. And S is the same thing as theta. So that's my connection here. So sine is still the y value, cosine S is still the x value, tangent is and cotangent are still the ratio of those two values to each other. Cosecant and secant are the reciprocals of my main function values. Okay, so none of this is new. It's just a new way to look at the definitions of my trig functions. So where I have the unit circle, x squared plus y squared equals 1, my formula for a circle is always x squared plus y squared equals r squared. So here my radius is 1. X squared plus y squared, x is not plus or minus, y is not plus or minus anything. That tells me that my center of my circle is at the origin 0, 0. So when I have the unit circle, it is symmetric with respect to the x-axis, the y-axis, and the origin. And we have already discussed this and gone through this. If you watched that unit circle video and have practiced walking your way around the unit circle, you know that you can find those symmetries. Therefore, if the point AB is on my unit circle, so is A negative B, negative A, B, and negative A, negative B. For example, I have the coordinates for my 30-degree angle. We're in quadrant 1, so they're both positive. Well, this angle, 30 degrees, is 30 degrees off of the x-axis, right? Over here, I have another reference 30-degree angle. There's my 30-degree reference angle. 150 is also 30 degrees off the x-axis. Now I'm in quadrant 2, so that x-coordinate is negative. When I move down into quadrant 3, and I use that reference angle of 30 degrees, I'm at 210 degrees, same set of coordinates. Now they're both negative because I'm in quadrant 3. And then once more over here in quadrant 4, 30-degree reference angle, same set of coordinates. X is positive, y is negative because of the quadrant I'm in. All right, now we talked about that with just that one set of coordinates, but like I said, if you've been practicing your unit circle, you know that that holds true for all of the coordinates for my special angles and even the non-special angles. If I found any reference angle in quadrant 1, I would be able to find that same set of coordinates in each of the other 3 quadrants, dependent on what's positive and what's negative. All right, because cosine of s is x and sine of s is equal to y, we can replace x and y in the equation of our unit circle, x squared plus y squared equals 1, and instead that gives us our Pythagorean identity. Now we've already looked at our fundamental identities, and the Pythagorean identity is one of those. Right here in our fundamental identities, sine squared theta plus cosine squared theta is 1, and then we derived the other 2 as well. So that's already familiar with you. Okay, domains of our circular functions. The domains of our circular functions are as follows. For sine and cosine, we can plug in anything. Anything's going to work, because sine is equal to my y value, cosine is equal to my x value, always over that radius which we are working with, the concept of the unit circle, so it's always going to be 1. Any real number, anything's going to work. Now when we are at tangent and at secant, tangent is y over x, and secant is r over x, because secant is the reciprocal of cosine. So let's go ahead and put that up there. Sine is y over r, cosine is x over r, tangent is y over x, secant is r over x. So for these two functions, I have x in my denominator. Well, anything's going to work here except where x is 0. So let's take a glance at our unit circle and think, okay, well, where is my x-coordinate 0? Well, my x-coordinate is 0 at the odd values of pi half. 1 pi half, 3 pi half. If I keep rotating around, I'm back here, this would be 5 pi halves, 7 pi halves, etc., etc. So any odd value of pi half, my angle will terminate on the y-axis, and at the y-axis, my x-coordinate is 1. So anywhere I have an x-coordinate of, I said that backwards. On the y-axis, my x-coordinate is 0, not 1. Anywhere I have an x-coordinate of 0, that function, tangent and secant functions, are undefined. So my domain for tangent and secant is restricted. It can be any value of s except at the k pi halves where k is odd. So tangent and secant have x in the denominator. So x can't be 0 for those two functions to be defined. I have to kick out of my domain any place where x would be 0. Now let's look at cotangent and cosecant. Well, cotangent is x over y, and cosecant is the reciprocal of sine, so it would be r over y. So now I have y in the denominator. So cotangent and cosecant have y in the denominator. So they are going to be undefined when y is 0. Y cannot be 0, and I have a function value for cotangent or cosecant. Where is y 0? X was 0 at the pi halves. Y is 0 at the full values of pi. So at 0, pi, 2 pi, etc. And I can just keep rotating around. Anytime I have an angle that terminates at one of those full values of pi, my y value is 0. And I have cotangent and cosecant undefined. Okay, finding values of circular functions. So as we look to evaluate those circular functions of real numbers are obtained just like trig functions of angles measured in radians. This applies to both to methods of finding exact values, like when I'm using my reference angles and special angles on the unit circle, and to calculator approximations. Calculators must be in radian mode when I'm finding circular function values. because S is the same as theta as long as theta is in radians. So that is key to using these circular function values. Find the exact values, and then it gives us -3 pi as our angle. So let's look and see where -3 pi is going to fall. -3 pi, well, I'm rotating clockwise. I've got 0, then I come back around a full rotation. That would be -2 pi because I'm rotating clockwise. That would be -2 pi over here. And then I need to go one more full value of pi. That gets me -pi, and then -3 pi is going to land here, -3 pi. So my -3 pi is this angle of rotation that terminates on the negative x-axis. All right, sine function value of -3 pi. Well, let's look at this. The coordinates here, because remember unit circle, so my coordinates are going to be -1, 0. My sine function value here is 0. That's the y value. My cosine function value here is -1. That's the x coordinate. Cotangent function value is going to be x over y, so -1 over 0, so cotangent here is undefined. Anytime I throw that 0 into the denominator, the function is undefined. All right. When we're finding these circular function values, we are making use of our unit circle. All right, let's do a couple more. We're going to find the exact value. So we're not using our calculator. We don't need to pick up our calculator at all. Using our unit circle, we've got a little unit circle here. You've got a big one handy. To find sine and cosine of 4 pi thirds. Well, let's find 4 pi thirds. Now 3 pi thirds is pi, so 4 pi thirds is going to be rotating past that. We're going to be down here in quadrant 3. So here is my angle 4 pi thirds. I've got my xy coordinates. Both of them are negative in quadrant 3. The sine function value of 4 pi thirds is the negative y coordinate, -√3 over 2. And the cosine function value here at 4 pi thirds is that x coordinate, a -1/2. All right, what about this angle, tangent? We want to find tangent of -9 pi fourths. Well, remember that tangent is y over x, so once we've got to figure out where -9 pi fourths would be. Well, 8 pi fourths is a full rotation. 8 pi fourths is the same thing as 2 pi. So that's 8 pi fourths is a full rotation. We're going in a negative direction, so we're rotating clockwise. So there is 8 pi fourths. 9 pi fourths is another pi fourth. So right there is a -9 pi fourths. It's going to be coterminal with 7 pi fourths. -9 pi fourths is coterminal with 7 pi fourths. And the reference angle is just pi fourth. So it's one of those 45s. Pi fourth, those all have the same x and y coordinates, √2 over 2. Since I'm in quadrant 4, x is positive, y is negative, so anything over itself is 1. In this case, it's a -1. It would be a -√2 over 2 over √2 over 2. Anything over itself is 1. All right. Use reference angles in radian to degree conversion to find the exact value of 11 pi 6. I nearly skipped that one. Let's do the same thing again, 11 pi 6. Well, where are we in relation to my rotations? 12 pi 6 would be 2 pi. So I am 1 pi 6 short of that. 11 pi 6, sine of 11 pi 6 is right here in quadrant 4. So that angle right there is my 11 pi 6. Sine function value is the y value. So that is a -1/2. Now, Haha, they wanted us to use radian to degree conversion. I totally ignored that. Here's why I totally ignored that. You're not going to see that instruction very often at all. In general, if you are given radians, stay in radians. If you're given degrees, stay in degrees unless you are told differently. I don't want you to have to depend on converting everything back to degrees. I want you to be able to start thinking in terms of radians. All right, new instruction. Calculator approximations. Calculator approximations. Now, it did not tell us how to round. We are going to round to 4 decimal places. When I round to 4 decimal places, oh, you know what? No, we're not. I just looked again at my answers, and we're not going to round to 4 decimal places. We're going to keep our significant digits. We're going to keep to our significant digits. Now, sine of 3.42, I know that this is an angle in radians. I know it's an angle in radians, or I can think of it as a circular function value s, because there's no degree symbol. So when I'm looking at my calculator, it is vital that I make sure that I am in radian mode. I'm not going to get the right answers. All right, so I've got it in radian mode, and then it's very simply just making sure I know how to use my calculator and hit the right buttons. Sine of 3.42 is a negative 0.275. Negative 0.275. We're going to keep those 3 significant digits. Here we've got 4 significant digits. Tangent, we got a button for tangent. We're in radians. 0.8234 is our value for s. So our tangent function value is 1.079. 1.079. Here I've got secant. Well, secant is the reciprocal of cosine, so that's going to be the same thing as 1 over cosine of that value, 5.6041. So I'm going to find this cosine function value, and then I'm going to take the reciprocal of that. You can set it up with the reciprocal first. I just usually don't work that way. 6041. I'm still in radians, so I've got my cosine function value. I need to take the reciprocal of that. I always do 1 divided by, and then just use my second answer option to bring that back up. So I've got 1.2851. 1.2851. Approximately, wavy equal sign for approximately. And then over here we've got cosecant. Cosecant is a reciprocal of sine. So sine of a negative 2.7335, and then I need to find the reciprocal of that. You plug that into your calculator. That should be the approximation you get out. Now always remember, you get to pause this video, slow things down, make sure that you can manipulate your calculator and find the values, take it at your speed. Let's go ahead and move on, though, unless you need to pause me, to that next page. Remember that when you're finding a circular function value of a real number, that calculator has to be in radian mode. Now, something else we've already discussed, those keys marked sine inverse, cosine inverse, and tangent inverse do not represent reciprocal function values. They enable us to find inverse function values. Inverse function values are when I know the value of the function. I know the function value, and I need the angle, or s. That's that backslash to mean either or. I'm looking for the angle, or I'm looking for the value of s. Because when I do an inverse function, I'm switching domain and range. I'm no longer plugging in one of these and getting out a function value. Now I'm plugging in a function value and I'm getting out either the angle or that value of s. All right, approximate the value of s in the interval from 0 to pi half. So that lets us know that we are in quadrant 1, and in quadrant 1, both x and y are positive, if the sine function value is 0.3210. So I've been given a sine function value. I'm going to use the sine inverse button to plug in that function value. Oops, 3210. I'm going to plug in the function value, and I'm going to get out a value of s, which is an arc length, the same as the radian value of a circle with a radius of 1. So sine inverse is that second function button. So I do second function, sine to get my sine inverse, 0.3210. And here I find that that corresponds to an S value, 326, and then we're going to round that to an 8. Now, when I am using inverse functions, the calculator is going to automatically restrict each of those functions to 2 quadrants, one positive and one negative quadrant. So when we think about those inverse function restrictions, so they say, okay, if sine is positive, well, sine is my y value. Sine is positive in both quadrants 1 and 2. If I plug in a positive value for sine, my calculator is going to automatically give me a function that's positive in quadrant 1. Sine is negative in quadrants 3 and 4. If I plug in a negative value for sine, it's automatically going to give me a function, an angle, or an S value that's going to terminate in quadrant 4. Sine is positive in quadrant 1, negative in quadrant 4. That's the restriction for my 2 quadrants for sine. In fact, that's the restriction for anything that is y dominant, so sine and its reciprocal cosecant. The calculator is going to give me values in quadrants 1 or 4. And then tangent, because tangent is y over x, tangent is going to return a value over here in quadrants 1 and 4. So sine is restricted, sine, cosecant, and tangent inverse functions are restricted positive values in quadrant 1, negative values in quadrant 4. There are other angles over here that have those same function values for sine, cosecant, and tangent, but the calculator is just going to give me one. And the one it gives me will be in one of these 2 quadrants, up here if it's positive, down here if it's negative. Now, my other 3 functions are x-dependent or x-dominant, and my x-axis moves horizontally. X is positive over here and negative over here. So it's not going to restrict my other 3 functions that are x-dominant to quadrants 1 and 4 because this would just be positive. Instead, it restricts the other 3 functions to quadrants 1 and 2. Cosine, secant, and cotangent are restricted to quadrants 1 and 2 because these 3 functions will be positive in quadrant 1, negative in quadrant 2. We've covered all the values. There are other angles down here that have those same function values, but if we're using our calculator, it's just going to give us that one primary angle or that one primary S value. Okay, so that's a good introduction to that. Let's move on to B. Find the exact value. So I'm not using my calculator. I'm setting my calculator aside. Find the exact value of S in the interval 3 pi half, 3 pi halves to 2 pi. So I'm in quadrant 4. So that tells me I'm dealing with a special angle. I don't need my calculator. I'm in quadrant 4, and I've been given a tangent function value. So tangent is negative in quadrant 4. That's to be expected. I know that tangent of S is y over x, and I've got square root 3 over 3. So my tangent function value in quadrant 4, that would be square root 3 over 3. It can't be this 7 pi fourths. It can't be this one. I know that because that's not going to give me that tangent function value. It's got to be one of these 2. Now I have to figure out, okay, which one is it that gives me square root 3 over 3? Well, if I start with this one, if I put this y value in the numerator, so if I chose 5 pi thirds, if I said, okay, what about 5 pi thirds? That means if I put this y value in the numerator, negative square root 3 over 2 over 1/2, the 2's are going to cancel, right? That just gives me negative square root 3, not negative square root 3 over 3. So that doesn't look right. Let's take a look at my other option here in quadrant 4, 11 pi 6, the reversed set of coordinates here. So tangent of 11 pi 6 is going to be a negative 1/2 over square root 3 over 2. When those two cancel, I'm left with a negative 1 over square root 3, and then I have to rationalize. And when I rationalize, this is what I end up with. So that value for s that I'm looking for is 11 pi 6. Okay? All right, let's do one more. Approximate the value. So I'm going to need my calculator. It's not going to be a special angle. I'm in the interval 0 to pi half, so I'm in quadrant 1. And I've given a cosine function value. It's positive. Cosine is restricted to positive values in quadrant 1, so we're in good shape. Since I'm asked to approximate, I know I'm not using my unit circle, I'm using my calculator. I'm going to use my inverse function button. So I've got 0.9685 as my cosine function value. As long as I'm in radians, when you plug that in, that's what you should get out. Okay. Our last page of notes for this section we've already seen. We started our semester the first or second section, I think, maybe third. I pulled this out, I pulled it forward so that we could look at very physically what these function values represent so that everyone has a good picture in their head. We are looking at quadrant 1 of the unit circle because my coordinate here is 1, 0. The arc S to R, SR right here, that arc that defines this first quadrant of the circle. Oops, that's my first answer. The arc is the first quadrant portion of the unit circle. Standard position angle, POQ, is designated as my angle theta. By definition, the coordinates of P, right here, are going to be cosine theta and sine theta. And the 6 trig functions of theta can be interpreted as lengths of the segments found in the figure. So very physically, we see that cosine of theta is the length of the x segment. Sine theta is the length of the y segment. So these are visual representations of our 6 trig functions. And you don't need to memorize these. These are just to help you grasp and have an idea in your mind about what we're working with. My tangent segment is right here in relation to theta. Secant is here if I extend that out to the tangent line. Cosecant is all the way out here that I extend my radius of my circle all the way out to the cotangent segment line. There's my cotangent segment. So there's another look at what those 6 trig functions would be. Okay, make sure that as you're working through all these things, you do the guided notes and then you stop and you go into My Math Lab. Every single section you stop and you go into My Math Lab. You do the homework assignment there. You look to see if there's a quiz yet. That quiz is like a little mini testing situation. You get 5 shots at that quiz. Take the quiz the first time through without help, And then go back after you see how you did, and if you need to try it again, try it again. Go back and review your notes, and make sure that you're not overusing all those homework helps that My Math Lab gives you. And then come back to Canvas and see if there is a written assignment. Come back to Canvas and see if there's a written assignment that you need to complete and submit.